so much for having me here. I also want to make an applause for the BSides Ahmedabad team. Thank you, guys. Really happy for being here today and to do the keynote talk. This is my title, A Methodology Using Fuzzing and Info Disclosure. So I haven't done this talk before. This is the first time. I wanted to make something special for you guys. So I hope you're going to enjoy this. I will have some time after for questions, and I really want to see the hands in the air and have some really fun questions. So, my name is Frans. I try to be open and talking about stuff in the bug bounty community. I work as a security advisor at a company called Detectify. I'm also a CTO at another company called Centra, which is not doing security related stuff, but more e-commerce stuff. I do a lot of hacking on HackerOne and Bugcrowd and some of the Synac, some Cobalt as well. But I'm trying to be all over the place, trying to identify where to look for stuff and what to actually find. And the idea of coming here today is that there's been a lot of advices, for fuzzing stuff, or looking for information, or trying to hack a bunch of companies. And I had some really fun examples that I wanted to talk about. And you all guys know the drill, right? As soon as you find something on a private program, you can't talk about it. And that's so boring. I don't want to do that. I don't want to try to censor all the images and try to explain why, or let's focus on the vulnerabilities instead. The companies doesn't really matter in this case. So what I want us to do, I want us to actually make up an imaginary app, and I will try and see if we can do this together. And the whole idea is that this app will be so generic, so you can kind of apply the bugs that we will talk about, which is real-life bugs. You can apply it to this, but there's no way you might be relating it to a real company because I won't disclose any company, but you can still apply this to the real life. That's the whole idea. So first, we will imaginary this app, and then we will try to use real vulnerabilities to try to show how to do this and how to use these techniques. You guys all with me on that? Okay, let's dig in. There's many ways to do this. This is just one way. This is not the only way. This is not the best way. I'm not saying that. I'm saying this is one way of doing this exercise and trying to identify these vulnerabilities. So the structure of our imaginary app will be very, very basic. We will have a single-page application on business.example.com. It will use a lot of JavaScript to do stuff. The only thing you will see when you sign in to businessexample.com is a website on businessexample.com. As soon as you start using this app, it will make requests to 3 other domains. It will use api.example.com for fetching user data, and use who is your current user, what other users are there, what company are you signed in with, etc., etc. On this business.example.com, you can also subscribe for different subscription plans. So you will be able to add your credit card, and you will be able to download existing invoices. And this company, they wanted to think in a microservice architecture. So what they did was they outsourced the invoice endpoint to be only providing data around what kind of invoices you as a company have. So that is not served through the api.example.com, it's served on the invoiceexample.com. All these requests are making sure that they're using proper authentication tokens and everything, so there's no authentication issue with this design, because it's always making sure that it's sending the proper authentication headers. The third thing this app has is you can talk together with other people in this app. So you can send DMs basically to other users. And they wanted to build that as a different team. There was a different team dedicated for doing the conversation endpoint. So they added another subdomain that will only integrate with fetching messages or fetching conversations. Pretty standard structure, right? You have a microservice architecture with some parts distributed into different subdomains, but you still have a main API that handles all the core functionality. Now, what we can see also in this JavaScript is that So some of the requests will go to the api.example.com. Like, as I said, the users, what kind of users, you will fetch all the user information from the api.example. As soon as you talk invoices, we will see that it has endpoints to invoices getting sent to invoice.example.com. What we can also see here is that the invoice team, the team building the invoice domain, they have iterated like 3 times on their API. So we have a version 3 for invoices. The third team doing the conversation.example.com, they have a different API. So when we're looking at the JavaScript, we see that you can actually fetch your messages from the conversation.example.com domain. Like 3 times on their API. So we have a version 3 for invoices. The third team doing the conversation.example.com, they have a different API. So when we're looking at the JavaScript, we see that you can actually fetch your messages from the conversation.example.com domain. Very, very totally normal structure. You have a distributed architecture, basically. Now, there's some ways forward. We now try to break this. This is our app. Let's try to identify vulnerabilities in this structure. And as you see, our imaginary app can probably be applied to hundreds of companies. It's a very generic structure, but we can still apply this methodology to all of them. The first thing is that we want to locate all the APIs that we can find and all the microservices used. Since we made the app right now, it's an imaginary app, we already know. We have API, we have invoice, we have conversations. All of them are being reached from business.example.com. So this exercise is over for us. If you would do the same exercise for a different company, you would basically look for other endpoints. There might be an admin.example.com. There might be JavaScript on the business side that when you log in as an admin, it makes additional requests to other endpoints. There might be legacy JavaScript somewhere where you can find old endpoints. So this exercise for us is very easy because we all know that they are just using these 3 microservices, but there's a lot more to do here if you're actually looking on a website or a company that you don't really know. The focus for us, however, should be number 2. First number 2 we will do is extract all the API endpoints that we see are being used. And we can do this very structured. We can focus from the JavaScript that we saw on business, we can actually focus and see, okay, let's see what endpoints are being used to fetch invoice data. And what we do is that we try, there's a lot of tools. There's like Jobert Abma have basically wrote something called a relative extractor, which is like extracting all the relative API endpoints in a JavaScript. You might be able to just extract all the strings from a JavaScript to actually just get the endpoints. You can literally search for // sometimes to get like all the strings that begins with a slash. It's probably a relative API endpoint, might be it. But what we did in this, we looked through the JavaScript, we tried to search for API/version 3, and we saw that these are the ones that we found. We found version 3 invoices, invoices/an ID, accounts and an account/ID. What we will do with this information is that we will store this in the best way possible for us to fuss further. One of the ways that I tend to do it is like this. What we can do here, we can basically say that this is a prefix. This is a path prefix, and there are most certainly more things under API version 3 than just invoices. Most of the time, they have something else, right? In this case, they have accounts and invoices. There might be, there might be payment methods, there might be users, there might be tests. I'm not kidding, like there might be a lot of these things. So we want to fuss everything under API version 3. So we're saving API version 3. We also save API, because there might be other versions. There might be API version 2, API version 5. We also save only the last part, the invoices or /accounts, because we want to separate them from the prefix we think is API version 3. But we still want to keep the full URLs as well, the full path. So we use API version 3 invoices. And as you see here, you have both invoices and invoices/an ID. This is a problem for us because we might want to also test invoices without an ID Sometimes an invoices, but only with the slash. Sometimes invoices.json. We want to test all these things. So what I tend to say is just an indicator. And this indicator for me is basically telling me that this is an endpoint that has an additional path on it, but it might also work without the path. And it might also work just with a slash. So it tells me those three things. So I can save space in my fuss list to say that this one should be tested with an ID and a slash and nothing and everything. So this helps me a lot into like curating this list. Because what we want to do now, we want to like find all words, phrases, everything that is being used by this company and combine that into a long list of endpoints so we can fuss that on everything we have on this company. One other endpoint that we saw was conversation.example.com. This one we find in the JavaScript has 3 other endpoints. It has /online, /conversation, /websockets. So we convert this, and we also know that you can identify a specific conversation with an ID. So we do the same thing. We save that star just for reference so we know that we can replace that one with a path or an ID or nothing. So now we have this to our path list, together with the other one. The other thing we need to do, we need to go into a lot of different assets to try to find more. Like what we did right now was we looked at the current JavaScript for the current website. That like this is the live things. These are the things that are currently now being live. But it might be an old version of these APIs. Remember we saw version 3 invoices? There might be an API endpoint with version 1 invoices. So we want to find all those things in all these different ways. Like, you can literally combine these two. You can go to Web Archive to find the old documentation. Perfect example of like, let's use Web Archive not to look at the code, look at the documentation from 2 years ago. That one had a totally different information in it. We might also look at other SDKs. Maybe they have an open source, like this is how you integrate with our business using our API. Maybe they have a desktop client. You can extract the data from the desktop client. What we then do is that we create a list of all the different endpoints. And this list we break out from the prefixes. So now we have 2 lists, 2 different files. We have the conversation, invoices, and users. And then we have all the prefixes of all the ones that we've been able to find. In this sense, we also we should probably add version 4 and version 5 to this list for this company as well. Because we're pretty sure that they will have some later versions, maybe not even used anymore, or yet. So when you do this and you combine it with all the subdomains, you can basically see here that now our fussing, just because we found version 3 invoices on invoice.example.com, our fussing by combining all these, we will actually do an api.example.com request with API version 1 with invoices. Something that we never saw anywhere on this site. But just because we separated all these things and then combining them together in our fussing, we will start testing endpoints that nobody else ever tested. Because why would they talk with invoices on the API? Well, it turns out one of the developers added a proxy that talks with the invoice API through the regular API endpoint, because why not? But nobody had tested that. Why would someone test version 1 invoices when we have an invoice.example subdomain? So this helps us in identifying endpoints that nobody ever tested before, just because we used our logic to separate all these things and then combining them together. So we basically take all the subdomains lists, all the path prefixes. Some of the path prefixes should be empty, right? Maybe we want to try api.example.com/invoice as well. We don't want to have any path added to it. And we add some standard parts to this, some standard fussing. Sometimes turns out like the version 1 invoice API on the regular API that nobody tested had a SQL injection in the ID of the invoice. I'm not kidding, like that's the thing that you might find just by doing these weird combinations. And remember, this is the company itself. Like, if you have a weird endpoint on one place, they probably use the same taxonomy. That developers want to be smart and think about efficient ways of doing stuff. So they want to like do the same kind of thing all over, right? They want to reuse things as well, so why shouldn't we reuse ourselves as well? So I tend to add these regular, bunch of characters, weird characters, backslash, slash, single quote, double quote, a person, like fragment sign, all these things. If there's numbers in the ID, test with letters, test everything, test minus. So when we do this combination, what might we find by doing this? And this is where the fun part starts, because I have examples for all these things. So one thing that we might find is that we can find new or old endpoints that is not in use yet or anymore. One really good example of this was a real-life scenario. It looked like this. There was a message board on one of the APIs. And this message board looks like this. You basically made like a version 2 boards and the ID of the message board. The message board would give you a list of messages for this specific conversation. If you look at the data, there's nothing really secret here. The message board was public for all the users. So one user could see messages from other users. That's the whole point with a message board. However, when we started doing our exercise, we broke up, the API part and the version 2 part and the boards. Suddenly, we get a different version 4/boards. And what we can see here is that a developer was refactoring their API into something called a JSON API. And a JSON API is basically a specification on how to do a JSON REST API. And what we saw on this endpoint was something called includes. If you know about JSON API, includes is basically an ability for the server to say that, you know what, I will give you the message boards, but also you have an option to include the whole user object if you want. And this is really convenient, because this means that in a regular case, fetching the message board, you might already have, information about the users, enough to actually just fetch the message board. But sometimes you want to, maybe on an iPhone app, you want to fetch everything. So you want to have the information about each user. So when you click on, a user, it will tell you and then tell you all the information about this user. Now, when we saw this, we basically realized, okay, if we add then a query parameter called include user, it would append an attribute to the response saying, here is the user. What was the interesting part here was that when they did the refactor of this message board on the version 4, they basically forgot to sanitize the user data to remove the private properties that should not be publicly available. But remember, they never used version 4 of the message board. They never released that. It never went into any reviews, because it's not being at use yet, right? It's not live, so nobody went through it and verified that you should not show these private properties. So what happened was, just by utilizing a non-used API that wasn't released yet, we saw that we could include the user, we added the include user, and suddenly we get data that we should not get. So now we can send our first report to this program. We tell them new version of JSON API for message boards leaks all emails and phone numbers for all users. Anybody that ever interacted with the message board has now a leaked email and password, just by us utilizing this new API. Another thing we might find is that microservices, remember the structure. You had an API, invoice, conversation. Maybe they also interact through making their own calls internally. This means that when you talk with the invoice API, maybe there's 5 microservices on the back doing certain things. Maybe they have an endpoint for internally to generate the PDF for the invoice. Maybe they have one endpoint for interacting with the payment methods, for adding credit card data. Because maybe they need to be PSI certified, PSI DSS, saying they can't handle credit card data themselves. They need to outsource that. So maybe they have a microservice just handling that kind of data. And we want to identify if any of the endpoints that we find interacts with something on their end, from the server-side perspective. And this is a really good exercise. And I have a perfect example of this, where I was able to identify that, yes, A microservice in the back was being used, and also a way to abuse it. This is what I saw. Remember our app. We have version 3 invoices and an ID. And remember what I did before, right? I had a star after invoices because I want to test without IDs, I want to test with IDs, I want to test with a slash, but I also want to test with like fuzzing characters. What I would do, what is the first additional request you would do if you saw this? What would you test for? 4 letters. IDOR, right? You have an invoice 1, 2, 3. The first thing you would do is to test like 1, 2, 4. You get an IP you get the URL for downloading the invoice that you own, but when you change it to 1, 2, 4, of course you want to test like, can I download someone else's invoice? It would tell you access denied. So now you know they have a proper access model of accessing invoices. That's good, right? But we want to fuzz this. So when we try a different ID, it tells us access denied. No vulnerability there, right? We try it with our fuzz list. We try double quote. It doesn't say access denied anymore. It says bad URI. Interesting. There's something other interesting on this one. Can you see it? Version 1. There's a difference here. This happened for real. And I saw this, and I'm like, I sent it to version 3, but it gives me an error of version 1. That is interesting. The URL I sent was with version 1. So why this? What is going on here? I have a possible explanation. I still don't know, but this is a possible explanation. The possible explanation is that the code they use looks like this. They have an endpoint on version 3 invoices. The route looks like this. You have API version 3 invoices. Everything after that will be our ID. Then, the function on the server side, still, we don't know if this is the truth. But this is a possible explanation on the error that we saw, is that they're making an API call on the server side end, and this server side call that they're making to an internal API we don't have access to, they're basically appending the ID to the invoice version 1. Because the internal API to download the PDF invoices is using version 1 instead. In our case, our assumption is also that how are they knowing that 1, 2, 3 we should have access to, but 1, 2, 4 we should not? Our assumption is that they actually append a token in the parameters. And I will tell you why. So this, of course, explains the bad URI at endpoint. That means that we send in double quote here, but this API call will say, but I don't know what URL has double quote. I will tell you no, this is a bad URI. And that's how we see that kind of error. Now, what we want to do now, the first thing we want to do is that we want to identify if our theory is right. So when I put the word fuzz in here, that basically means that part we're going to test with a word list of regular parameters. So you understand what fuzz means here. Fuzz means anything that we want to test. We want to iterate and see if we can find any differences if we're testing like the word API or the word user or the word token. We want to test, iterate, and see if we see any differences. So our first practice that we want to do is that we want to send and verify that we can send additional query parameters, because our assumption is that there's an API call on the other end that we want to inject query parameters. We want to do like a query string smuggling on the internal API call. So if we would send the first request you see here, if we would send that one, those query parameters will never be sent to the internal API. Because as you remember on this one, here it appends its own query parameters. So this one will ignore those query parameters. However, if we URL encode, we might get lucky. Because this part will now turn into ID. From here over to here. And if we're lucky, they actually URL decode that part, or the routing system does it by itself. Like that's what's going on. In some of the routing systems, this URL decoding is handled automatically. So they will never see the URL encoded part. They will actually get as the ID, the question mark part, and the person thing. So we start fussing this and try to see what happens. Now, our theory is that the server-side call will look like this. This is the part we inject, and hopefully we will get in the token in the internal API request. So we do this, and we fuss all the words that we have. There's like there's a burp parameter list that you might use that is like really convenient. It has all these regular ones. And we run this, and suddenly on token, we get access denied. This is awesome for us. This is an indicator that token that we sent in as X made the request saying access denied. And remember, this is to the invoice that we did have access to. But just by appending a query string with token X, we don't have access to it anymore. So this tells us that token parameter is used for authenticating you on the internal API. So even if we get access denied here, we are really lucky here because we have identified that we can do query string smuggling to an internal API. We know exactly how the authentication works. This is everything we know, and we just got an error access denied. That's everything we needed. Now, the interesting part is that what we want to do here is that we won't be able to get a different invoice. We don't know the token of a different user, right? How do, that we can smuggle in our own token here does really not help us, right? It won't help us to get 1 through 4 because we don't have the user token for different invoices. We don't even know what our token is. We have no idea what the token they are sending to this endpoint actually is. So what can we actually do with this? Well, we can stop doing a query string smuggling and start doing, yeah, this is basically the confirmation of this. We can start doing path traversal instead. The interesting part with path traversal is that we now know that we are talking with an API on version 1 invoices when we're sending it to version 3. We know we can smuggle, but we can also eliminate tokens in the query string. And we know we're talking with invoices on the other side. So let's us instead move out of invoices. Let's use ... URL encoded and try to go outside the invoices part, but in the internal API. So we URL encode this and we start fussing. But what we also want to do is that we want to eliminate the token parameter. We know that the token parameter was used to validate that it's a user sending the request. So our assumption here is that if we talk with a different endpoint, that endpoint, might check that, but there's a user token here. The user token should not be used in this internal API call. So what we can do, because we know that we can smuggle query strings, we can also eliminate query strings by using fragment sign. %23 is URL encoded fragment sign, which means that if we send this, if we do a path traversal back out of invoices, and then make a fuss list of the parts that might be in there, and then use the fragment part, we know that the request made to the internal API will not use the user token anymore. And this could actually help us. This might mean that they have a check making sure that no users are talking with other endpoints. And therefore, when the token is in the query, they will just say access denied. This user is not allowed. But what happens if this internal API basically just checks if the token is there? But if it's not there, it's a legit request. This happened for real, so this is actually a case. So what we do is basically run this on the fuzzing list, and suddenly accounts gives us data. And you remember from before, we saw version 1 or version 3 invoices, but we also saw version 3 accounts, right? So we know that one together with the token in it. And when the token, we already brute forced our own version 3 on the invoice API, and that one didn't give us anything interesting. But now when we use the fragment sign from this endpoint, eliminating the token parameter, we actually get data. And not only data, we get all the invoices for all the accounts. So this is our second report. We have a report now, path traversal getting access to all invoice accounts due to the fragment elimination of the token string and a path traversal to the internal API. Perfect. This is a critical. This is the assumption that we have that the request was looking when we actually got this working. We made a request to the version 3, but that one made an internal API call to API version 1 invoices. It made a path traversal back to accounts, and then we eliminated the token parameter. So the token parameter is not in use. Another way forward is that let's look at other things in the JavaScript. Let's not just look at the API endpoints. Let's look at what kind of other strings are in this JS file. And what we might find by doing that is that we might find keys or tokens that are expected to be secrets. And you know what? Like, if you have a company and you have a JavaScript file, you probably don't have your own internal API keys in the JavaScript, right? That would never happen. I mean, it will happen. It has happened a lot of times. But hopefully you don't have that. But the thing that you should think of is like, there's a lot of third-party applications out there. And those third-party applications might have really sucky documentation that is not really clear if this API key should be public or not. There might also be third parties that are intended to have public API keys, meaning that you should have the API key in your JavaScript. It's a legit usage of it. One example that I want to show you is something called Sendesk SSO key. Has someone ever used Sendesk with an SSO key? Oh, okay, interesting. This is good information. So what I found in one of the JavaScript files was this. You had a ZD key and you had a CD access URL. CD stands for Sendesk, and what you see here is you saw like a hashed API key, and you saw this access JWT. When I saw this, I'm like, yes, I have API key access. I can just go to the Sendesk API for this customer, and I can just get all the data. I took the key and I made a call to the Sendesk API, and they're like, no, this is not an API key. This is not even how the API key looks like. So I'm like, what is this? The interesting part here was the access JWT. I started searching for how Sendesk uses access JWT. And it turns out they use it for SSO. And SSO means single sign-on. So basically how it works is that, let's say you have an app and you want to have like a link that says, go to our support. And what you want to do is that when they click on that link, if you're signed into the website, they want you to be signed in on Sendesk as well. So they use this JWT to transfer data over from the company website to Sendesk. And they want Sendesk to unpack this JWT and basically sign you in automatically. And you probably see where we're going with this. Having this key means you can sign the JWT yourself. The JWT looks like this. You basically have 5 parameters. This is like the Sendesk JWT solution for a single sign-on structure. The first ones are basically just a date and a unique ID. They can be whatever. The time needs to be very much aligned to the current time, so it's like a Unix micro time of the current date, so they can like expire if the JWT is too old. The second part, or the third part and the fourth part is basically the name and the email of the current user that you want to sign in as. But the interesting part is that Sendesk doesn't really care what you send in there, as long as it's a unique email address. The interesting part is the fifth one, the user ID that you want to hijack. And remember, user ID on a website tends to be a public thing. If you have profiles or conversations between 2 users, you probably will see the user ID. It's not a secret. Some of the users are numeric IDs, right? If you can sign this JSON and send it to Sendesk, you will sign in as the user ID provided in the data. Meaning you will see all the support tickets this user had. You can just find the user ID and then sign in as that user in the support panel, asking them to change email to your email. So this is how it works. You sign the JSON with the JWT and you send it to the access JWT for this customer, and then they will give you back a session together with a fast digest, which is basically like, this will sign you in as that user. So now we have our third report. Account hijack on the support panel because a publicly disclosed Sendesk SSO key. And this is the only reason why this was a vulnerability, was that they didn't read about how this logic worked with this send as a secret. They didn't know that it was a secret, because it basically said API key, and it's not an API key but because the API doesn't use it. So they're like, oh, this is probably not a secret, but it actually is. Another thing that we might find, another example, is basically something that is intended to be public. This is an Algolia API key. Does someone recognize an Algolia? Have someone seen Algolia like looking at the JavaScript before? Raise your hand, please. Okay, some of you. All right. This is not intended to be a secret. This is actually public information. If you're using Algolia, you're probably using it for autocomplete, for a fast search solution on your website. Like these parts that you see here is not secrets really. They are intended to be used on a website publicly in the JavaScript. So no vulnerability here really. We see that the database or the index name is literally called public database. And when we make a request, we can actually take these three things. We have the API key, we have the app ID, and we have the index name. As soon as you have those three, we can actually make a request to Algolia itself. And then just make a query with a star sign or an asterisk and see what the data contains. This will give us the first result of the query. When we see that, okay, it has a user ID and a username. That's it. But what we might do when we see this is that we might look at if there are other indexes that we might talk to. We look in the code, we try to see that, okay, there's not only a public database, because when we talk about user database, Algolia will say, uh-oh, index is not allowed for this index, or for this API key. So now we know that the API key we saw was scoped. Scoped means that they have said that this should only have access to the public database. But what we have right now is that we have the app ID, which means we can search for, in all the information we have about this user or this company, and we can look for the app ID because the app ID will contain this database. We know there's a relation between the app ID and the database called UserDB, and we know that the API key we found was scoped to not view. And we start looking at the web archive. We start looking at the history of this website. We start looking at other JavaScript files on other subdomains of this company. And suddenly, we found another API public key. So this public API key was an old one that was being replaced. But we make the same request to user database, and suddenly we get all the users. So we try to figure out, okay, so this another public API key, what really happened there? And the theory is, they basically had an unscoped API key back in the day, and they moved to a properly scoped one because someone said so, but they never forgot to revoke this old API key. They just thought it got vanished in the depths of internet. But we actually found it because we looked at the web archive, and now we have our fourth report. We basically get emails and phone for all users disclosed due to a sensitive data in a publicly open Algolia database. This database was supposed to be public, but they utilized Algolia also server-side because Algolia is awesome. You want to use it because it's so fast. So instead of only having public data there, they just added private data in Algolia, and they thought they were smart because they scoped the API key they currently use, but they forgot about revoking the old ones. That's what happened. Now, another thing we might find when looking at the JavaScript is that we might find environment variables that was used in your CI minification. This is a very, very common issue. So when people are building the code for their website, using continuous integration, CI, Jenkins, Circle CI, whatever they use, Travis, sometimes when they build the code, some of the modules that they use, in Node, for example, or in Composer or similar, they actually dump the environmental variables when building it. It sounds ridiculous, but it's 100% true. This has happened multiple times, that when you actually look at this, you would see this in the JavaScript. Is anything standing out and screaming vulnerability in your face when you see this? Yes. Yes. You have AWS access key for the production, and you have an AWS secret access key for production. They were just dumped there in the CI minification of their JavaScript, and they never thought that that would ever be a public thing, right? But suddenly it's just in the JavaScript code. So what I did in this example was I loaded my CLI version of AWS. I used the secret key and the access key. I ran Scout 2 on it just to verify that like these are actually working. And I asked the company, can I like check what they are doing? They said, yeah, but we probably will notice that you're doing that. And I said, oh, that's fine. And I made like an S3 list, and I got all their buckets that they ever used for everything. I had their Terraform scripts for provisioning. I had their CloudFormation scripts for provisioning. I had their source data. I had their public logs. I had everything that they had was with these keys. That was accidentally published due to minification in their CI. Here's a guy with a horse. Another thing we might do is creating word lists. So this is the kind of essence that I want to like tell you that it's so important. Because some of the vulnerabilities was by combining, understanding the context of like the parts of the APIs. We wouldn't be able to find the endpoints that we actually showed you if we didn't create these word lists. And I do this for every program. I try to take, internal indicators. So we have the different indicators telling us that we reach internal stuff. I tend to use like a subdomain list, so we know what subdomains are working for this company. I tend to use all the paths, all the prefixes, all the endpoints. So we have all these for this company, because this might be invaluable in a couple of years that we want to test this program again. And it's so easy to go back into context because you have all the API endpoints. You also want to build and combine. And one really easy way to actually do this, let's say you've been using Burp for a long time, and you've been playing around with the website, and you just want to extract all the data. There's certain things you can do. One super easy way is just literally to select in the proxy history, select all the, sort on URL, take all the API endpoints, copy paste, go into the console, PB paste in macOS, for example, and then you cut it on the delimiter tab character, and the fourth parameter, in my case, URL is like the fourth. I think that's the default in Burp. You will get all the paths. So I will just sort them by being unique. And then now I have like my first word list. In this sense, I will start using this data to start separating them to my different lists that I want to combine. This is just like a really quick way to just get all the things that you've been playing around with to get like a list for being used for these word lists. Super easy. Another thing we want to do is we want to apply context. We want to show why humans are smarter than machines. So in this case, we see this. We see version 1 payment methods, and we see version 1 shipping. In this sense, we would literally like, okay, what can we add to this list as a human? Probably a machine, but this is a pretty basic example. But as a human looking at this, I would probably add shipping methods as well. Because that's what developer does. They want to reuse things, they want to have the same kind of pattern all over, so why wouldn't we? And remember, this shipping methods was never disclosed in any way in any JavaScript. But just because we are looking at it, we kind of see that it makes sense adding that one, because that looks similar to other things that we've seen in this API. Never disclosed anywhere, but still we will check this endpoint just because we apply context to this logic. And the last part that we want to do is we want to fuss. Like, I can't stress this enough. We want to test so many things. We want to test all the HTTP methods, post, patch, delete, put, head, all of them. We want to test with IDs and not IDs, and with slash and not slash. And we want to test .json and without the file extension. If you always have file extensions, remove those file extensions. We might want to test without them. We are black boxing here. We don't know anything. We want to test everything so we can kind of see how they are working, how they're behaving. GitHub literally released, there was a guy doing a blog post just like, I think it was a week ago or something, where he literally said that he could bypass OAuth because he was sending a head request to an endpoint that had an if statement saying, if get, no validation, else, like skip validation because a post can always are validating CSRF tokens. Because the if statement said, if yet, show this page, else check the CSRF token. But the thing was, head was never like sending a CSRF token, but the code path basically said the CSRF token is already checked. So just by that if statement, just by sending a head request to an endpoint, they bypass the whole validation flow, so you can add whatever OAuth app you want to GitHub. So by testing all these endpoints, you would literally find that bug using this methodology. Also, again, you want to combine all the paths and endpoints. You want to have empty paths. You want to just test the endpoints. You want to skip paths. You want to try all methods, add regular fuzzing characters, backslash and person and fragment. You want to test all these things. Null characters. Literally, there are a bunch of places that just crashes, gives you a stack trace just by providing null characters. Always keep it in your fuzzing. So two takeaways from this. You want to create your own context-specific word lists. You want to combine everything with regular fuzzing that you've already done anyway. But now you have context. Now you can reach endpoints that you never reached before. And you also want to understand and learn when it's being disclosed. Remember the bad URI? The bad URI told us so much information just by an error. There were no access disclosed. It was just a different error message for when we were doing the fuzzing. That told us so much with so little. And that's it. Thank you very much. So, any questions? Do we have time for questions? I hope so. I don't know. Raise your hand if you have a question.
What's your favorite fuzzing tool?
My favorite fuzzing tool. I use Intruder a lot in Burp. I use WeFuzz a lot. I think I haven't found my favorite fuzzing tool yet because I don't think it exists. I tend to, so what I see with the problem with fuzzing tools is if they only check status code or only check content length or only check what kind of data is getting outputted, you will always miss something. So I wanted to be much smarter than just checking one of them. I wanted to check one or all of them or none of them. Like I want to combine that logic in a very specific way. And I want to have it as smart to actually understand how it's supposed to do it by using, it's testing an endpoint that it really knows doesn't exist and then compares all the things, but still understand that if you're sending a word that is really long, the content length will be longer because it reflects it, right? So stuff like that. And I haven't really found that to be, the easiest one is Burp because you can sort it and sort them yourself.
How do you categorize real-life vulnerability versus unrealistic vulnerability?
Oh, I couldn't hear you, sorry.
How do you categorize real-life vulnerability versus unrealized vulnerability?
How I create...
How do you categorize real-life vulnerability versus unreal vulnerability?
Sorry, how okay.
How do you categorize real-life vulnerabilities versus unreal vulnerability?
Oh, that's a good question. Okay, how I categorize real vulnerabilities with no vulnerabilities. And I think it's also context related. So sometimes you need to understand. A good example of this is IDOR, right? So in a bank, if you would be able to do an IDOR and see someone else's bank statements, that's a vulnerability. But if you're on thinking about Bitcoin, looking at another wallet is per design a proper way to use Bitcoin. So you can't really talk about an IDOR being able to look at another wallet in Bitcoin because that's how it's supposed to be done. So it's all about context. It's all about understanding what's the dangerous things for this company. So it's not an easy answer. You won't see a comment in the code saying this is a vulnerability. That you might see that, but I mean that's not what's happening most of the time. So a lot of the times you need to understand if this company, and you can verify this on other things, right? So if you would go to in the example of us getting the email and the phone number of the user, if we looked at looking at the regular user endpoint, when you go to a profile for another user, you would literally they see like, but there's no email address here, there's no phone number here. They don't want to show that for all the users. Of course they don't want to show that. Why would they disclose that data? But when we saw it on our different endpoint, we kind of realized this is not intended. This data was not disclosed before, but only on this endpoint I was able to get the email and phone number. So that kind of gives us an indication that if this endpoint is so different, showing the user, there must be something wrong with this endpoint. It's disclosing too much data, and that's the kind of vulnerability that we identify. So I hope that's a good answer to that.
What processes can be followed to protect against these API attacks which you have talked about?
Yeah, help me to the mic. Can you? Yeah. Sorry. Much easier to hear.
What software processes can be followed, development processes, to protect against these API attacks which you have talked about?
So I tend to, as a developer, I would look into making sure that the APIs we're using are the ones that actually work. So one of the examples I showed you was that they had version 3 invoice. You should make sure that like version 2 and version 1 doesn't even exist anymore. Like when you're actually moving your things, or like another solution is to make sure that you also are checking those for the same kind of vulnerabilities. Like one of the examples I had was that a new API was disclosing email data. That's a really hard one to catch because the developers might not even introducing it in the documentation or Swagger or something. They just introduced it because someone was refactoring their APIs and they haven't even put it up for review. So it's really hard to make sure that like all the endpoints that we have that we're testing them. But like one of the things that I tend to do is that one thing could be that you automate creating Swagger files internally based on the routes that are being evaluated. Instead of disconnecting the Swaggers, so a Swagger is made by hand, you will always have a disconnect then. So I tend to like force people to have some form of automation to disclose what routes are actually active. That way you'll be able to identify that endpoints you're not using anymore are still publicly available. Or new endpoints that is not in use anymore are publicly available. So that might be like a good solution to it, because there will always be a disconnect between the published Swagger, if you have that publicly, and the actual real-life scenario routing. That's literally the first thing I do when I meet a company that I want to look at together with the developers. I'm like, give me your routing file. Like, give me all your routes. Some of them sending me a link to the public Swagger. I'm like, no, that's not the truth. I want the routes from their code. Like, okay, the Swagger contained 15 paths, but when you look at the routing, it has 25. And then you understand there will be a problem for sure. So that might be a good training session to actually extract them from the real code instead of having the disconnect to a manual. I hope that's helpful.
Thank you.
Thank you. Thank you so much, everyone.